Hi Declan. I believe
Hi,
you're good to go. We can start.
we can start. Okay, just one second. One of my colleagues is trying to join as well. Just one second. Okay, I think we can make a start. So welcome everyone to tonight's exam preparation course for the Institution of Structural Engineers. My name is Declan McCaffrey. I'm a structural engineer. I've been in the region since in the Middle East since 2008. Currently working with Mott MacDonald and currently a committee member of the UAE branch of the iStruct. I'm joined today by fellow committee members Basil and Hemant. So thanks for attending both. Uh, so first of all, just a mention of our sponsors, Hempel, who are long-term sponsor of iStruct. They provide intumescent and durability coatings for steelwork, and also to our silver sponsor, AGSI, Arabian Gulf Steel Industries. So today, we'll just maybe for 45 minutes or 50 minutes, we'll just discuss the different aspects of the iStruct Chartered exam, the structure of the exam, how the marks are allocated, suggested timetable, what level of detail to go into when answering the questions, method statements, and also what a good answer script looks like. So just for people that are not, we say, fully familiar with iStruct, but in order to become MI-Struct, there's two things you need to do. You need to pass the professional review interview, which involves compiling a portfolio of work and doing an interview. And that's one half. And then the second half is the chartered member exam, which is an exam where you get the chance to demonstrate your ability as a structural engineer and to show that you have a good understanding of structural engineering principles. So this here is what we're focused on today. So basically, the UAE branch of iStruct, we're doing this exam preparation workshops over the next few weeks. This is week one today. I'm going to give a talk purely on time management in the exam, not so much technical stuff, but it's a challenging exam in terms of managing your time. So this should assist you in your preparations. Then tomorrow we're going to issue, everyone that attends, we're going to issue a sample paper or sample question. The idea being that you will attempt that question under exam conditions over the next few days. And then next week on the 10th of June, we'll have another workshop and you get the chance to share screen, share your solution with us, and you can get some positive feedback from whatever committee members will be attending. I think next week it's myself and Hemant that will be assisting. Then on the 11th of June, we'll issue another paper. And the following week, we do the same thing. You get a chance to share your answer. And then the following week, if there's people that want to have a one-on-one session with the committee members, we're free to, we can arrange for those meetings. And then the next chartered exam is on the 15th of July. This is what a sample question would look like. Basically, there'll be 5 questions in the paper, and you get to pick one. You'll get some high-level outline sketches. There'll be a description of the building, the loading, site conditions, ground conditions. And then there's the main part of the question. The first part is you have to come up with 2 different schemes for the building. You have to answer a question that the client may have. Then in the second part C, D, and E, you have to produce calculations sufficient for initial structural sizing of the members and pricing, and some carbon calculations. Then you have to produce some drawings, general arrangement drawings, and then a detailed method statement, and the mark allocations are beside each part, which we'll go into in a bit more detail later. You need to pass both section 1 independently and section 2 independently. About 2 years ago, there's a slight change in the format of the exam. Now, sustainability is a key aspect of the exam. When you develop the two schemes, you need to use sustainability as a criteria and recommendations. Whichever scheme has got the least carbon would get some points or be preferred. Lots of information on the iStruct website. So if you can scan this QR code or just go to the iStruct website, go to the climate emergency, lots and lots of information. But essentially, you need to be able to do some basic carbon calculations. How much embodied carbon is in a steel beam? How much is in a pile cap or a column or in situ concrete beam? Just approximate so that you can show that you have an appreciation of the sustainability. So what are the issues with this exam? It's quite a challenging exam, but oftentimes you read the examiner's report every year and they often come up with similar statements like this. Time management is always a problem, and this question was no different from many other candidates. Section 2E, which is the method statement. Some people run out of time and don't get time to even attempt this part, so you lose out in trying to gain a few marks at the end. Hi, Lucas, how are you?
Good. Can I just tell you something?
No, I'm doing a seminar at the moment, Lucas. Okay.
Oh. Look, your mom's banging book.
Thank you, Lucas. So basically, this is the structure of the exam. A 7-hour exam. It's open book. That means that you can bring in all the code references that you want, but you'll probably find that you don't really have much time to learn stuff for the first time, and some shortcut cheat sheets would be much better than bringing in lots and lots of books. Before the exam starts, you're given the 15 minutes before the exam, you're given the exam paper and you're allowed to read it, but you're not allowed to write anything down. So in that time, you can choose which question you want and start thinking out possible solutions. So no computers and no electronic devices. You get 30-minute break for lunch. There'll be people there invigilating the exam, but they're non-technical, so you won't be able to ask them any technical queries or any clarifications on the exam. Okay, so the exam is not split into concrete and steel. It's split into sections. You'll generally have a commercial type building, industrial building, some bridges, small scale, miscellaneous projects, refurb, maybe a stadium. The structure types, the solutions you'd be looking at is multi-story buildings, long span buildings, bridges, grandstands, underground structures, private housing, unique structures. So you probably find, based on your experience in industry, whatever company you're working for, one of these questions you'd probably gravitate towards one of these questions in all the papers. Okay, so the new format, the key differences. So previously it just said that you had to produce two distinct solutions for the structure. Now they say two distinct, viable and sustainable solutions. So you need to use sustainability when you're assessing your two schemes. Also, the more different your two schemes are, the more marks that you get. Should demonstrate minimizing structural material through efficiency, consider reusing some structures, include the benefits, use sustainability, And then in your communication, you don't have to write a letter anymore, but it's a professional email. Don't use any shortcuts or text type speak. And then you need to learn how to do the basic carbon calculations for some structural steelwork or reinforced concrete. There's no program anymore, but you do need to do a method statement, which is the last question. Okay, so two distinct and viable solutions. So basically, in terms of stability, you got shear walls, you could have cross bracing, sway frames. For the framing, you should alter the column spacing and the layouts. One scheme could be precast, in situ concrete, another could be steelwork. Foundations could be piled, pad foundations, strip foundations, or rafts on ground improvement. Just to make sure that both schemes, both options or both schemes are different. So the different materials, generally concrete, steel. I know in this region, timber and masonry not used so much, but they are viable structural materials. Try to get different load paths in your two different structures and maybe a different construction method. Try to get some modern methods of construction into one of your solutions, precast or modular offsite construction. So basically with the sustainability, it's mainly the main way you get a sustainable solution is by using less material and have an efficient design. There is an extreme situation here where you could question the brief and you could ask the client if he actually needs the building at all in the first place. Difficult for us structural engineers to ask those questions, but it is something we should be thinking about. Section 1B, where you'll be asked, the client was going to ask you ways to make his building more efficient, more sustainable, and how he can save some costs. So this is your opportunity to think beyond the criteria that will be given in the question and try to communicate other options that you can give to the client in order to save material and lower the cost. One simple example could be you could suggest restricted access to the roof, and you may be able to reduce the live load design, live load requirement, which would reduce the demand on the structural elements and have some saving. Okay, sticking with sustainability again, because it's worth noting that this is now a big part needs to be addressed in the exam. You can scan the QR code here to bring you straight to the climate emergency page in the iStruct-D. And it's about learning how to do some A1 to A3 carbon calculations. There's a little bit more. This slide is really just demonstrating how much information is available on the iStruct-D website. Later in the presentation, we just have a very basic carbon calculation for a pilot cap, which we can take you through. When we say A1 to A3, what we mean is how much embodied carbon is used in extracting the raw material from the earth, transporting it to the factory, and manufacturing the final product. That's A1 to A3. Transporting it from the factory to the site is very, very negligible carbon. And actually the cost of installing it on the site is also quite small as well. So most of the upfront carbon is the A1, A2, and A3. And you can see here, A1 is raw material supply. So that's about extracting stuff from the earth. If you can then imagine if you do recycling or reuse, you totally delete this section, which has carbon benefits. Okay, so with your part 1B of the question, again, the examiner is testing your knowledge to think outside the box and to write a professional communication. Focus on material reduction, communicate the impacts in terms which the client can understand, and include both environmental benefits and other potential benefits, cost and program. Also include there might be some downsides or negative implications of what you're suggesting that the client can weigh up against the positives. Keep it brief and to the point. And you can include some sketches. Okay, so the mark allocation. So previously, so basically just some advice really. First impressions last. Have neat work. Do lots of mock papers. Your script should be easy to follow. Make the examiner's life easy. Convince them that you have good engineering knowledge and are a good communicator. You need to communicate your ideas, otherwise you'll not be awarded sufficient marks. So the part 1A, which is the main part of the question, is 160 minutes. It's 40% of the marks. The part 1B, which is the email, is 10%. Part 2C, which is the calculations, is 22%. 2D, which is the drawings, is 20%, and the method statement is 8%. If you take any advice from today's webinar, it's really allow yourself some time for part 2A and pick up as many marks as possible. So 7-hour exam, 420 minutes, 100 marks. So 4 minutes per mark. So that means after 40, you get 40 marks in 160 minutes, you'll be done. So, but what you can do is, you can split up. We have a table later in the presentation about the actual time to spend that will allow you 20 minutes at the end to check your script. So this is the sample questions, and we've just highlighted in yellow the bits that have changed from previously. Section 1A, use sustainability as a key criteria. So you don't ignore the other criteria, you keep going with the constructability, sourcing of materials, fire resistance, durability, all of that still, you still address it, but you just need to include sustainability. And this part 1B used to be a letter, but now it's just thinking outside the box. The client is asking you for ways to come up with a better solution and some suggestions. And that can be different to the criteria given in the beginning of the question. Part 2 was always structural calculations, some connections, some reinforcements, and a bend and shear and that. But now you need to include, not in great detail, but you need to include some basic carbon calculations. And then this part at the end, section 2E, it's a method statement. You're not expected to do a program anymore. Okay, so the timetable. So stick to your timetable. If you don't get something finished, move on. If you have a few minutes at the end, you can go back. But the main advice is when your time allocation is up on a question, spend 10 seconds writing to the examiner saying what you would do if you had more time, and then move on to the next part of the question. You will gain more marks in the beginning of the next part of the question than you will at the end of the previous sections. So be sure to start or to attempt all sections of the questions. Okay, so these are part 1A. You have to develop 2 options and give a recommendation. So we're saying 50 minutes for option 1, 50 minutes for option 2, 20 minutes for the recommendation. If you pass this part of the question, you're very likely to pass the exam. So really need to focus on developing your skills in developing different options and different concepts, different solutions. Okay, the part 1B, which is the professional communication or email, 30 minutes. Calculations, 1.5 hours. Drawings, 1.5 hours. The method statement, 30 minutes. And then around 30 minutes at the end to check. So when you do preparation questions, should be stick to a timetable, something like this. You might want to alter it slightly different to suit your own needs and your own experience. This is a good guide to use as a base. Okay, so the basically the setup on the day will be as you say, you're given the exam paper 15 minutes before it starts. You can read the question, think out the two schemes, write the two schemes with sketches, load paths, basic outline sizes, span over depth ratios. 32 marks for that, 16 each, and then recommending a scheme, 8 marks. Professional communication, 10 marks. Then you got the calculations, including some carbon calculations. Drawings, very important, the drawings also. There's 20 marks, but what happens if you read the people that actually mark your paper, what they do when they get your script, they go straight to the drawings and have a look at it to see what the solution is. So if you can do a good set of drawings, you will be demonstrating to the examiner that you're a good communicator. And also regarding the drawings, what you have to imagine your client, when you give him the calculations and the drawings, he'll probably put your calculations to one side. He'll take the drawings and he'll send them to the quantity surveyor and ask for a price. So sufficient for pricing. That should be the level of detail on the drawings, with some 2 or 3 enlarged details to show that you know how structures come together. Yeah, so 3 details, enlarged details. It might be to do with some curtain walling or some cladding or transfer structure or a cantilever, but whatever is, there'll always be something slightly different on the question that the examiner wants you to focus on. Okay, so level of detail. So again, 7 hours is not much time to do a full schematic design of a building. So you just have to do as much as you can, touch on everything, and try not to get sucked into doing too many calculations, especially not repetitive calculations. So form and size, like I said, basic grids, span depth ratios, reinforcement quantities. Must check critical aspects. So this is also important. I touched on it a minute ago. Your question will have something unusual. It might be a transfer beam or an unusual cantilever, or there'll be something there that needs your thought. So don't ignore it, because that's exactly the examiner wants you to focus on this thing. We call it the golden nugget. Find the golden nugget. Find what's different in your question, and get two separate solutions for the issue. Okay, so again, develop shortcuts, proximate approaches. Again, there's no laptops allowed. So basically, WL squared over 10 or 12 for the average bending moment, top and bottom in a beam. All shortcut calculations that you'll need to learn how to do, and you'll also need to learn how to do them fairly quickly as well. So manage your time well. Decide quickly which members are principal beams. So if you design a main beam, you may design one secondary beam, but that would be it. If you have a main beam that spans 10 meters and another beam that spans 8 meters, you would just design the 10-meter beam. You've demonstrated that you can design a beam where there's 10 meters or 8 meters. Doesn't really matter. So go for the main framing members. Again, try not to do any repetitive calculations. One beam design, one slab design, one connection design, one column design. Just a little bit on the A1 to A3 calculations. Again, if you go to the climate emergency section on the iStruct website, it'll give you all the information that you know. But this is the embodied carbon, 0.138 for a cubic meter of concrete in the UK. And this is the embodied carbon of a ton of reinforcement in the UK, produced by electric arc furnace, 0.760. Now, these figures vary from country to country, and they also vary over time. As factories get more efficient, these embodied carbon values go down. So it's always changing. So no need to be concerned about that. Pick one, reasonable one, and use it in the exam. And basically, all you have to do, this is how much embodied carbon is in a cubic meter of concrete. So you just calculate how much concrete is in your beam, and you multiply it by the embodied carbon. So this particular one is a pile cap. The pile cap is 2.1 by 0.9 by 1.4, and the weight is 2,400. You multiply it, and you get 876 kilograms of embodied carbon in the pile cap. This is not per cubic meter, but per ton. Okay, and then the reinforcement. Again, you multiply the weight of the reinforcement in your pile cap by the embodied carbon value, and you get 231 kilograms per pile cap. You add the concrete and the embodied carbon for the concrete, embodied carbon for the reinforcement, and you get 1,107 kilograms of embodied carbon per pile cap. So it's just one or two basic calculations like that. The other way to look at it is if you imagine a quantity surveyor doing his job, he'll work out the volume or the weight of the concrete or steel, and he'll multiply it by the price per ton. All we're doing here is we are replacing the price per ton with the embodied carbon per ton or per cubic meter. Okay, so method statements. Again, it's part 2E, and a lot of people run out of time and don't attempt this question, even though it's worth 8 marks. So practice your method statements, do some research on how buildings are built from the beginning, right, from taking possession of the site right up to and handing over the keys. Consider the proposed construction sequence to enable the works to be carried out in a safe and controlled manner. And also avoid generic statements. Basically, like I mentioned earlier, your question will have something unusual in it, and you need to address that when developing the schemes, when doing the calculations, when doing the assessment, but also in the method statement. So just a few points on the method statement. Site setup, clear the site, carry out underground survey, provide health and safety signs, prepare the area, erect the facilities, provide hard standings around the compound, access roads, storage areas, temporary services, and site facilities. Check the above below ground services, check site investigation, carry out pre-construction requirements, check ground conditions, foundations, excavation, temporary support, reinforcement cages, holding down bolts, place, vibrate the concrete. So these are the sort of details you need to go into. Superstructure, concrete frames, and again, if your building has something unusual, like the transfer beam, needs to be addressed in the method statement. Also, it's worth stating if there are any specific local authority or municipality requirements. We've had a case before where, like in the UAE, oftentimes if you do a diaphragm wall for the foundations, you also have to build another wall, permanent wall inside that. That's not the requirement in other areas in the world, and it's sometimes viewed as being conservative. But if it's a local authority requirement, then we should add that to your notes and your sketches. Okay, so what success looks like. So if we just, I always advise if you do a question under exam conditions, what you should do is after you've done it under your 7-hour exam, then afterwards get the examiner's report, read the examiner's report, and you can assess yourself, see how you did in the question. It's always very useful and a good way to learn what the examiners are looking for. So method statements, mostly acceptable where candidates had used their time wisely. Good candidates use sketches to illustrate the erection sequence. So basically, again, they're just referring here to the fact that people don't leave enough time to do the method statement at the end. But if you manage your time wisely, you'll be able to make a good attempt at section 2E. Again, just the usual comments from examiners. Many candidates ran out of time at this stage, produced only generalized list of construction activities. So again, this just stresses the importance of when your time allocation is finished for a section in the question, then stop and move on to the next section. General comments, again, it's a similar theme through the examiner's report. A fair number of cases, poor time management, poor time management, and some time pressure. So again, the way to overcome this is to realize that you don't have to do a detailed design of each structure. Try not to get sucked into too much detail. It's a scheme that works, is sustainable, is reasonable, but you don't have to do a detailed design. You don't have to detail out every connection or every part of every reinforcement. Okay, have a sustainable answer. Do just enough design checks. Don't be too detailed and don't be too simplistic. So this only comes with practice and by reading examiner's reports. Use section tables. You don't have to calculate things from first principles, and use the design guidance, span over depth ratios, etc. Produce a good email. Focus on the fact. No need to go off on a tangent. Just try and answer the question that the client has asked. Do 3 details on your general arrangement drawings. The rest should be enough information sufficient for pricing. Okay, don't rush the method statement. Think out how you're going to construct the building. On the iStruct website, there is a lot of guidance, exam preparation guidance. There's some exam preparation courses that you can do. My advice on this is to do as many questions under exam conditions as possible. Get up early in one morning, sit down and spend 7 hours doing the exam. And then afterwards you can read the examiner's report to see how you did. So again, do mock exams under exam conditions and just keep doing it. And the more you do it, the more chance you give yourself of passing the exam. So just a few tips from my side. Again, part 1A of the question is the most important. You need to develop 2 schemes and they need to be different. So if we just take, for example, scheme A, we just say you have a concrete frame, 9 by 9 meter grid. Your stability is shear walls, and you got piled foundations. So that's considered a good scheme A. So scheme B also needs to be good, needs to be complete, but it needs to be different to scheme A. So you could do a steel frame with metal deck, because that would be different to the concrete frame. You could change the grid from 9 by 9 to 12 by 8. Instead of having instead of having shear walls for stability, in your scheme B, you could have cross bracing or moment frames for stability. If you've got piled foundations for scheme A, you should consider a raft, pad foundations with or without ground improvement for the foundations. So these two schemes can be considered very different, and you would gain good marks by doing that. The only other thing to keep in mind is that you will be proceeding with scheme. You will be proceeding with, we'll say, scheme A here. But the scheme that you leave behind, it needs to be every bit as good as scheme A. There's also the thought that scheme A, if there's an error in it, you'll be able to find it later on in the day. Scheme B, the one you leave behind, you don't have that opportunity. So the scheme you leave behind needs to be, it's okay, Lucas. Okay, so the scheme you leave behind needs to be every bit as good as the scheme A, and I would suggest that it even needs to be slightly better. Spend an extra few minutes doing some extra checks. Okay, so just on this as regards different schemes and different concepts. So this here is sort of reasonably common where you have a concourse level in a hotel, for example. And you're not allowed to have any columns in the concourse in the reception. So you need to design the transfer beams that's supporting the floors above. So this is one answer, the sort of more straightforward one. So let's say this is scheme A. So for scheme B, if you change this transfer beam from concrete to steel or to post-tension steel or truss, post-tension concrete or a truss, you won't get well, you wouldn't get any marks basically because it's basically the same thing, just a different material. You need to come up with something different, something very different. And this is one possible solution, that you actually build the outer columns up. You put truss across the top and you hang the floors from a big truss at the top. Now, this types of structures do exist. There are a lot more things to consider, but you do gain a bit of extra headroom here. But also when you build it, these columns, the outer columns, will be built first before the floors. They won't be getting the restraint of the floors straight away, so these columns could have large effective lengths. But this is a very different scheme to the transfer beam, and you would gain good marks. There's a third option, that you just convert all these beams and columns to Vierendeel girders, which wouldn't require any. You're basically turning the whole structure into a big old deep transfer beam. This is an example of some buildings, one in Dublin and one in Bahrain, where all the structures are hung from large beams in the stair cores. So how much detail to put on the drawings? So I've put two sketches here, and one on the left being a pad foundation with some reinforcement and the column rebar. And then on the right is a similar sketch with some notes. So basically, if we look at the detail on the left, if you're the quantity surveyor, you would need to work out the length of the reinforcement, the weight per meter, and come up with the weight and how much concrete. Now, this detail here may look quite detailed, but it's missing some vital information for the quantity surveyor. There's no dimension from the ground level to the top of the foundation, and there's no thickness of foundation here, and you don't know if it's a pad foundation or a strip. So this has insufficient detail for a quantity surveyor to price. If you look at this detail on the right, you can see here 400 by 400 column, 280 kilograms per meter cubed. You got the ground level, 450 thick, 450 millimeters to the top of the foundation. Then you got a 3 meter by 3 meter by 0.6 meter pad with 80 kilograms of rebar per meter cubed. A quantity surveyor would have that priced in a few minutes, I would say. And it's got all the required information that he needs. Also, for yourself in the exam, this detail would probably only take 1 or 2 minutes, while this one may take 5 minutes. So generally on your drawings, just keep in mind that just imagine the drawings going to a quantity surveyor. Does he have enough information? Does he know how deep the excavation is? How much reinforcement, how much concrete is in the building? Then a level of detail like this, you do 3 enlarged details in your drawing package. It might be, like I mentioned earlier, some curtain walling or cantilever detail that you need to do an enlarged detail of. Show dotted lines for ceiling and services and finishes, just to show the examiner that you know that it's not just the concrete structure that's been built. There's a lot of architectural and MEP stuff to follow. That actually brings me to the end of the presentation, and we hope you found it useful. Keep in mind that tomorrow we'll be sending the attendees a mock a question that you can do, and then on the 10th of June we can have a workshop to discuss your solutions. So that was it. I might pass over to Hemant or Basil to see if there's any questions in the chat box.
Thank you. We had one question from attendee, and he requested handbook. Can you suggest some handbook resources containing thumb rules of designing various elements in a building? So I gave 3 handbook. First, Concrete Center, which has published for element sizing for different type of slabs. It covers 1-way, 2-way, ribbed slab, waffle slab. And the second book, which I recommended, Declan, it is Fiona Cobb, the pocket book. And to answer the quick rule of thumb, there was a publication in AISC how to pick the steel profile if we just know the bending moment. So that also very useful. Only it is in American unit, so we can convert it to our 345 megapascal steel stress, and because always in steel deflection will be governing. So once we check deflection, we'll get a moment of inertia and we will pick the section.
Okay, yes, yeah, and I'd forgotten about Fiona Cobb's book. It's very useful with a lot of good shortcuts. You may also end up developing your own shortcut page with your favorite formulas that'll save time in the exam.
So we request participants. Yeah, we have a second question from our participant. Let me read. What is the maximum number of times I can take this exam? Is there any time framing to clear the exam? So if you allow me, I can answer this question, Declan.
Yes, yeah, please, yep.
So there is no limitation on number of attempts or number of times candidate can sit. But let me ask you, like we will be spending fees for exam. So if we prepare and practice and go for exam, that will make sure we pass. So that's why the regional group has prepared this workshop, and the same thought came to my mind. Why candidate fail? So there are 5 things which comes to mind why candidate will fail. The first reason, we miss stability aspect. If we have not provided a stability system in either direction, it's a direct failure. Plan bracing. Suppose if it's a steel structure, it will require a plan bracing to transfer forces to the strong point. So stability, which includes plan bracing, vertical bracing. Second reason, if there is a client requirement, and if I miss to read the client requirement and I added extra column or I didn't fit my solution as per the restraint or constraint written in the exam, definitely I will be considered fail. The third reason, which this presentation clearly said, focusing too much on one section only. This exam is about passing both the section. So if I answered, like I developed two concepts perfect, but I didn't develop details which are required, or I didn't develop plan, section, elevation. Here I can use magic of symmetry. So if structure is symmetric about one axis or two axis, circular, I should use the symmetry to put only the portion of complete building instead of putting complete. So that's why, like, why you should prepare when we will distribute question paper tomorrow. So there are only three simple reasons why you should participate on 10th. You, like, during this time you will prepare and you will submit the script. Why? Because it will tell you what are your strong points, where you need to put more efforts during this time before examination. And like it will we don't want you to sit continuously for 7 hours. You can sit for 3 hours, next 3 hours, and complete your 7 to 8. Like if you take 10 hours, no problem. So you will come to know, okay, I have to do something fast. So these are key three reasons, and we will provide constructive feedback, like where you did good and where you have to put more effort. So these are three key reasons you should actively participate in solving the question paper, which will be distributed by regional group. And we were at the, like, why candidate fail. So we saw about stability, we miss the requirement, we do not give justice, and our schemes are not different. Like if I put same base spacing for both steel and concrete, so it's a direct failure. Like both steel, it is a stronger, so it can span longer. So such basic things, if I miss, if my both schemes are carbon copy, so definitely that will be the first direct failure points. And as an engineer, our language is sketches, drawing. So uh, if I can able to explain email using sketch or figure, it will be good. It will save the method statement which Declan give example. So sequence of construction was explained by sketches. So it will make big impact. And here I would just ask you, like if you have been given a two story book, one story book which has a pictures and another story book, it has only text. Which one you will buy? And definitely, like uh, uh, I can guess your answer. It will be the storybook with sketches, figures, or pictures. So let us put pictures to put our ideas, scheme, like our thought process. And I would one more thing which comes quickly to my mind. 15 minutes is only for reading. We don't do anything. Like if you take after that some time to plan, like what can be two different schemes. So give time for developing two different viable scheme. So that, like if you put more time on thinking, you can utilize the time to draw something on a paper, like how you are developing from destination A to destination B, like complete scheme. It will carry, like it examiner will understand your thought process, like how you arrived at this solution. So don't like if you are doing some rough work, everything we will put in a answer script. So everything will become a final version. So this is from my side, Declan.
Yes. Yes, thank you, Hemant. And yeah, I think when you do the exam first, when when you do the exam paper first, it's going to take more than 7 hours. When you do it the second time, it'll be a bit less and a bit less and a bit less. So no need to be concerned if the first time it takes a lot longer. There is a question as well, Hemant. I was thinking of you as well. It says, my experience is in oil and gas onshore structures. How is that relevant to the exam?
Okay, so this candidate, he's attending our webinar regular basis. I have observed him dedicated. So, like, there is a one question which always, like, what is a type of question which comes in an exam? It is challenging. So, what challenging means? A long span, a long cantilever, column free. So, these are all the challenges. Ground where we have a two different borehole, weak, like the ground which will require some improvement or piling. So these are all the challenges which comes to mind. So in oil and gas, the engineers, they design a long span shelter, a workshop. So these are steel structures which will span maybe 30-meter, 40-meter column free. So similar question is coming most of the time in an exam, or a long span stadium. If you are prepared yourself with all catalog which are required for a long span steel structures, like what can be a different boundary condition, fixed portal frame, pin portal frame, use of steel joist, use of what we call castellated beam, cellular beam. So, like if you have read and you have done some scheme of similar structures, you can attempt this type of question. So, like questions are not oriented towards only one industry. Uh, like I understand in oil and gas, they design a long span steel shelter workshop, so he can attempt this type of questions. Sometimes, Declan, there are questions on water reservoir, large capacity water reservoir, or
Yes.
maybe like one time we had a question on uh, Crocodile Park, so which was a water retaining structure, a pump house. So similar
Yeah.
questions definitely will come. So you have to go with all preparation. As you rightly said, like we don't design wood or masonry work, but if I have like what is allowable stress in timber, deflection, modulus of elasticity, if I went with all this database, I can attempt something like which comes like which will I can attempt. So let us
Yeah.
go with all preparation. If we don't go with preparation, definitely we will not able to attempt a single question.
Yes, thank you. Okay, I think that's it in terms of questions. Just to note that this webinar will a copy of it or recording of it will be posted on the UAE Regional Group's channel, YouTube channel, in the next day or two. So I think that brings us to almost to the end. I think Hemant has something else to add.
Yeah, like Declan, we have a good survey data available with our regional group preparation course. We have observed like the candidate who come and present, they have good chances of passing the exam. So make sure this is the historical data which we have. The candidate who actively participate, presented, he was able to
Yeah.
get success.
Yes, yeah, and it's not when you present your answer, it's nothing to be concerned about at all. All the feedback is positive, and we're working on the basis that everyone will learn from you presenting your script. So it's to be encouraged. Thank you. Okay, well, thank you, Hemant, and thank you, Basil. Thank you very much, everyone. We'll bring the webinar to a close now. So thanks for taking the time to tune in and listen to us. Thank you. Bye.